I emphasize the importance of coordination in creating value, but let's look at what happens if coordination fails. What is the cost we have to pay as an individual company or as the supply chain as a whole? What is the cost? What is the consequences when coordination fails? There is a very famous example, the very famous, well-known concept, which is Bullwhip effect, which usually is believed to be one of the most serious consequences when coordination fails. And think about this situation. As usual, we have this supply chain function, supply chain systems, suppliers, manufacturers, distributors, and customers. And now let's say that consider consider product whose demand is usually very stable. In other words, it does not involve too much peak and downs and so on and so forth. So usually the end market demand is pretty much stable. But now, for some reason, let's say this is due to some random cause or random phenomena. Whatever the reason, there is a short period of time or maybe one discrete event when the demand actually increases, maybe sharply increases due to some random event or random phenomena, which is kind of normal, which is kind of abnormal, right? Considering this usually stable demand patterns. So when we look at these customers' demand patterns, we don't see much fluctuation. We know that there is one small peak, which is not that significant, not that serious, but nevertheless which is not normal considering this whole regularly stable patterns of the demand in the end market. Now, what does the distributor see? I mean, what's the kind of impression this distribution function has when it observes this kind of a short, very small fluctuation? The distribution function fluctuates accordingly, but it seems like the distributors but somehow magnifies these fluctuations. In other words, it's the magnitude of fluctuation is larger, and also it seems like it takes longer to return to the stability. In other words, as we move backward, as we move towards upstream of our supply chain, this small disturbance, this small irregularity magnifies further. And if we go one step further backward, if we move one step backward, then we see the fluctuation becomes even larger. So the manufacturing function, when it observes what happens in the distribution function, it prepares itself, or it sort of responds to its own observation, what happens in the distribution. What about this supply function when we go back a little further? It seems like the suppliers also feel something wrong in the manufacturing, and suppliers themselves have to work something in order to cope with that fluctuation in their own customers, in this case the manufacturers. So as we move backward, the fluctuation becomes even larger, and it takes even longer to return to the stability. All these are variations, right? All these are variations or variations and variability, and this implies that as we move backward along our supply chain, it seems like our uncertainty magnifies significantly. So uncertainty increases significantly. In order to explain this phenomenon in a more systematic way, I want to introduce a new concept, the concept about information quality. In other words, when we have information, how much reliable that information is, how much accurate that information is, how precise that information is, right? So information quality is information quality implies the accuracy, precision, and reliability of that information. And now, in the previous slide, when we talked about Bullwhip effect, it seems like as we move backward, our information quality seems to decrease, right? Information quality becomes worse and worse as we move toward the upstream functions in our supply chain. In other words, the accuracy, precision, reliability continuously decrease as we move backward. As the information quality goes down, the uncertainty goes up, right? So I would say that there is that relationship. Information quality goes up, that implies uncertainty goes up. Information quality goes down, uncertainty it goes up. So why that happens? What actually determines this information quality? I would say that there are basically two factors that affect the information quality. In other words, information quality is a function of two factors. The first one is distance, right? The first one is distance. Distance between information source and decision point. What is information source? Information source is the place where that information originates. In this case, we are concerned with this market demand information, so the information about the market demand, and therefore the information source of that demand information is the market, the customers. What is the decision point? Decision point is where you have to make a decision based on the given information, based on the information given to you. So let's say that if we look at the supply function, that is the decision point, and then information source is with the customers. Therefore, if we evaluate this information quality at the supply function, we have to look at the distance between information source and decision point. So as you can imagine, the longer the distance, the lower the information quality. In other words, as the distance between information source and decision point becomes longer, the information quality will go down further. So there is sort of an inverse relationship. As the distance increases, the information quality goes down. I want to make sure that here the distance is not just physical distance. It can be physical distance, it can be psychological distance, and it also can be emotional distance. For instance, if the information source and decision point, there are some people involved there, and the person and the information source and the person and the decision point, they don't have good relationship. In other words, they fight each other and they disagree with each other. At a personal level, they dislike each other. And then I would just say that even if these two people are in the same office, their psychological distance or their emotional distance is quite far away, right? So when I say distance, it is not about physical distance. The distance is about not only physical distance but also psychological and emotional distance as well. And the second factor that determines the information quality is number of gatekeepers. Number of gatekeepers between the information source and decision point. As the number of gatekeepers increases, the information quality will go down. That's kind of very obvious, right? Whenever there are many intermediaries between 2 points, the information is easily distorted and information can be quite incomplete. So let's put together all these things together. Let's see what's happening here. This is the Bullwhip effect, right? This is the Bullwhip effect. As we move backward, the magnitude of fluctuation increases, intensifies, and the time to stability, in other words, the time in order to reach the stable situation, in order to reach stability, it takes longer. So here, the end market, the fluctuation is not that big and the time to stability is very short, but as we move upstream, it becomes more and more damaging, more and more serious. So as we move from this customer market to the source, the supply, the magnitude of fluctuation increases, and also time to stability increases, and that means that uncertainty increases. And we already know that other things being equal under regular context, as uncertainty increases, your inventory will go up as well. So your inventory goes up. And then we know that there are some consequences of having too much inventory. What are they? First, your inventory management cost will shut up significantly, and your innovation speed goes down significantly, and also your learning capability or problem solving capability goes down significantly. And therefore we can see that these are the consequences we can see when the coordination fails. In this case, specifically information sharing is the coordination area, but we can extend this case to other coordination areas as well, like new product development and the joint decision making and R&D activities. If we fail coordination, if we fail to coordinate for these activities and these subject and these activities, then eventually we have to pay lots of cost, and this cost must be borne by not only the individual firms in the supply chain, but also the supply chain as a whole. The supply chain as a whole must pay prices due to the coordination failure, and that's one of the clear examples why we have to make sure that there is a high level of coordination throughout the supply chain in order to enhance efficiency driven value and also responsiveness driven value at the same time.